you have this particular thing. And here is the block. This is 30 degree. Mu is equals to 0.1. Okay, you know what is mu, right? Coefficient of friction. Consider G is equals to 10 meter per second square. Yeah, and this particular thing is basically bound with a pulley like this, where we have this is 10 kg mass, this is 5 kg mass. Okay, so this will be going downward with the acceleration A, in this direction with the acceleration A. Here it will be having some tension, here it will be having some tension. Now the thing is, when you consider this particular distance, this is 1.25 meters. Okay, this is object A, and here this is object B. Okay, this is object B, and this is the point G. Okay, so first question: calculate time taken to hit G when object is released from rest. Object is released from rest from point P. Is released from rest from point P. Okay.
So the first thing we need to find is the acceleration. We know the acceleration is consistent. I guess we do that through the FT stuff. FT on both objects is equal, right? So then we know that there's a force friction, though. That changes things. I don't know. We've done these sorts of questions in class. It should be a little bit easier for me to approach, but it's just that this is 2.1, 2.2. So I haven't done that since, the first test. It's mostly just been energy stuff.
The entire unit is coming, right? If I'm not wrong.
Yeah.
Yeah.
Yes.
So you should be, now the thing is, this particular thing is the free body diagram along with the kinematics, where you are basically determining the acceleration, and then you're applying the kinematics to determine the time. Okay. Yeah. And both of these are basically doable ones. They are not difficult ones. Okay. Trust me. So try doing this one. Try doing this one, then I'll give you little more.
Hang on.
Questions.
Mg sine theta plus mu mg or plus mu mg cos theta.
The first step is to draw the
equal to force tension. Yeah. So we know that Ft can be equal to mg sine theta plus mu mg cos theta. So basically mg of sine theta plus mu cos theta if we factor it out. Ft is also equal to the weight of the other thing, which is, well, 10 times g. 10g, I guess, which is again like 10g. We know that m is 5 here, so I don't know. That means that mg sine theta plus mu cos theta is equal to 10g, where m is 5. Get rid of g's, those cancel. So there's a 5 on the side, which means that sine theta plus mu cos theta is equal to 2, which is equal to Ft, I think. Or both of those expressions should be equal to Ft. I think you can just calculate force tension. So then why bother with most of this in the first place? Why the simultaneous equation? I don't know. Something I've done is bad.
Okay, tell me your both the equations. Tell me both your equations. I'll just write it down.
Mg sine theta plus mu mg cos theta is equal to Ft.
Wrong. The thing is, I'm saying that like this is going with acceleration A. That means there is resultant force. So 5A
meaning that they're not equal. One of them
they're
is
not
greater.
equal. Definitely, they're not equal.
Yeah.
So 5A is equals to T minus 50 sine 30 plus 5 cos 30.
Yeah, so I just my bad. Sorry.
Then 10A is equals to 100 minus T. Cool? Come on, determine the value of A here quickly.
What's the best way to do this? Was it?
Hello?
Oh,
Yeah.
right. It's just to subtract things.
Can you please tell me the answer for this one?
Oh,
70.67 divided by 15. What is it?
4.7.
4.7 meter per second square. Now we got the acceleration, and then we already know the displacement. Okay, we got the acceleration 4.67 meter
You
per
know the
second square.
distance s is equal to ut plus 1/2 at squared, where s is equal to 1.25, u equals 0. T doesn't make any sense though.
Really?
We know the acceleration, but why use t? We don't know t.
1.25. We'll be using s is equals to ut plus half ad square. Okay, where
We
u
don't
is
know.
0.
We don't know t. That's
We
why
are
I don't want to
determining
use it.
t. That's the question. You have to determine t.
Oh, because we know s, u, a, t. Okay.
Yeah. Okay. So this will be half ad square. So half minus half into 4.7 into t square.
Yeah.
So tell me, what do you think should be the answer?
It's a little less than half a second. I can actually wait. No, can't be because it's square rooted. So therefore, whatever result I end up getting is going to be very different. Yeah, it's a little under a second, 0.73 seconds.
All these things doesn't matter. Like once you know the tactics, okay, you should be able to do like a lot of questions. Okay, the thing is like we are giving you kind of questions which will make you, which will help you in doing like 100 other questions. Okay, yeah. So this is like different type of question. You are being familiar now to all the types of questions which are possible. Okay. All right, here I'm giving you a question. Let's say that this particular ball, this particular object, it is in equilibrium, okay, at 25 degree, okay. Here it is going backward with a certain acceleration, certain acceleration. There is some tension over here, okay. Yeah, and g is equals to 10 meter per second square. All right. So find a.
Find a.
And this is in equilibrium. Okay, this is an equilibrium. I mean that
This is
this is
in.
basically the point is that here it is ma, it is going backward with ma, but it is being balanced at this particular point. So this is fixed at 25 degrees. Okay. Initially it was like
Okay.
this, and then it is going backward with certain acceleration. Yeah. Come on, do it. So what is a?
Second. T sine 25 is equal to ma, right?
Are you sure a sine 25?
Yes. I mean, no, a is not sine 25. T sine 25 is ma.
Hello?
But no, that wouldn't make sense either way because it's in translational equilibrium. But then again, you
So
could also say that T
again,
cos 25 is equal to mg. Wait, so is it just that it's accelerating there or that way, or like is it a force applied to it? That's specifically we're looking at.
okay, yeah. So you're
Hello?
doing it, right?
Yeah, I am, but can you hear me?
Yeah, I can hear you now. Yes.
Okay. Yeah, I was just asking, like, it's a force being applied to the ball that's pulling it to the left, right?
No, the thing is basically the object, this entire system is going forward, because of which this bob is going backward.
Oh, okay.
I remember giving you similar type of question.
Yes.
Come on.
Trying to think. Is there anything else we know besides the angle?
Nothing.
Just an angle, not even the mass of the body.
No.
So we're told to express something a certain way or
No, you have to find A.
numerically. Okay. So I'm just an idiot.
See, when you are given the tension at a specific angle, one thing you should understand that like you need to basically get the components of the tension.
Yeah, I've already done that.
All right. So we are having one component over here, another component over here.
The only issue being that now
And there
you
is
have
weight.
3 variables you're going to be juggling around like an idiot. So minus 1.335.
No.
1.335 isn't even the magnitude.
Oh, you said 4.335.
1.335.
No, I don't think so.
Wait, is it 4.335?
4.335, I think that's correct. But you said 1.335.
I mean, see, what I've done here is just exactly what I think you were hinting at by drawing the MG stuff. Is that a terrible?
T sine 25 is equals to MA. Then T cos 25 is equals to MG. So T sine 25 is equals to. Okay,
oh wait, hang on.
Then get tan, man. Like sine 25 divided by cos 25. That's tan 25.
Yeah, but it doesn't really matter because
I just
Huh? Oh no, it doesn't. Yeah, T got canceled, but I don't care about that because it doesn't matter. It should be the same numerically. Anyways, I realized what I did wrong. My calculator was in radians, not degrees. It's 4.663.
Yeah. So
yeah,
this is
4.663.
Yeah. So 4.66. What is it?
4.663.
All right. 663.
I had my calculator set in radians, not degrees. So.
All right. No problem. Okay, Ryan. So this is another type. Let me give you the third question. Suppose here is a cart. Okay. This is the wheels of the cart. It is basically having 4 wheels basically. 2 wheels are not like quite visible basically. And here is a person. Okay. Now the mass of the cart is 100 kg. And the mass of the person is 50 kg. Okay. This is frictionless flow. Yeah. Now this 50 kg person is walking in forward direction. Okay. Is walking forward with 3 meter per second. Okay. 3 meter per second with respect to the cart. All right. You're getting it?
Okay.
Let me tell you one thing, that this entire system, because of the person walking in forward direction, this entire system will go in slightly in the backward direction, actually.
Yeah. Yeah.
You need to determine with what velocity it will be going backward.
With what velocity it will be going backward?
With respect to the ground. With respect to ground. Okay.
So, okay, the man is moving at 3 meters per second.
Forward.
We had an acceleration that might. We only have a velocity. I don't know. We could say that T is 1, but that doesn't really make sense for me either. Essentially, the force required to move this guy is going to be the same force that he applies to the cart in order to move. That force, of course, would be MA, where his mass is 50 kilograms.
Use momentum. Use law of conservation of momentum.
Momentum might be better. You're right, actually. We are given two masses. 100 V is equal to 50 into 3. 50 is equal to 100 V, which would mean that V is 1.5. The cart moves backwards with 1.5 meters per second velocity.
1 point?
5. 1.5. I mean, it's like if you use conservation of momentum, it takes 2 seconds. 50 times 3 is equal to 100 times V.
Let me think. 50 times 3 minus V is equals to 150 times V.
Wait. 3 minus V.
This
Why
is with
3
respect to
minus V?
cart.
Because he's the cart. With respect to the cart, though, isn't this guy at rest?
With respect to the cart, the person is going forward with 3 meter per second. So with respect to the ground, you will be taking with reference to one surface, right? So both the velocities, V and this the velocity of the person.
Oh, we have to find the
Simply-
thing with respect to the ground. Okay.
Yes.
And with respect to the cart, he's moving 3 meters per second. Okay.
This is with respect to ground. This is with respect to ground.
Okay.
Yeah. So that is equals to 150 V because V is backward. Yeah.
Yep.
And so yeah, equating it. So 3 minus V is equals to 3V. So
Divide everything by 50 for 4V is equal to 3. V is therefore equal to 3/4, 0.75. Yeah, cool.
yeah, cool.
Yeah, sure.
Okay, Ryan. We'll stop here.